A very good morning, Willem.
Yes, good morning to you, Fredos.
How are you doing?
And good afternoon, I assume, to the other participants.
Yeah, good afternoon to my colleagues in Ifakara and Kenya and Malawi. We will have hopefully people from different countries joining, same as before. How have you been, Willem? How was last week?
I've been fine.
That's nice.
But as you may have heard, the corona situation here is rapidly deteriorating, just like it is in the US, actually.
Yeah.
So we keep ourselves very, very much restricted, mostly at home.
Yeah.
I think that's probably the best option until we can get vaccinated.
Yeah. I don't know, but I think that I saw yesterday there was an approval of the Moderna vaccine as well. So now you have more candidates coming in, and I looked at the roadmap for it. I think we have like five that are about completing the phase 3 as well. So
yeah,
so there should be quite a number of candidates for selection.
Yeah, they expect 5 or 6.
Yeah.
But the good news is still, of course, that at least here in Europe, the younger population is hardly affected. They become infected,
right?
But their symptoms are extremely mild.
Yeah.
And most of the serious illness is actually with the older generation. And the government feels very strongly they need to be protected as soon as possible.
So that means when the vaccine comes, they will prioritize that group.
Yeah, yeah.
Well, I've been studying this now a little bit, just wondering whether the vaccine strategy should exclude people who have potentially been infected.
That has been a point of discussion here as well.
Yeah.
But unfortunately, there is no scientific evidence yet, not enough, to say that people who have been infected and recovered are properly protected, because we think at the moment that this vaccine has a lifetime duration of maximum 1 year.
Oh yeah?
Yeah, a bit like the influenza vaccine.
So all of them, or just the messenger RNA vaccines?
Excuse me?
All of the vaccine candidates, or just the messenger RNA vaccines?
It's too early to say, of course.
Right.
That's where everybody's living in the middle of an experiment. And it's a huge experiment, and we just have to see. To my great sadness, of course, is that with all this attention on corona, we tend to lose control of the other least known or tropical infectious diseases, including the funding that is necessary for it.
Right.
Because this whole corona thing is going to last 2 years, if not longer. And fortunately, the heart of Africa so far has not been very much affected.
Right.
At least by far not so serious as other countries. But look at South Africa, where it's
and Egypt.
And Egypt, yeah, but that's not the heart of Africa. That's those are the edges.
Yes. Right.
So you may actually wonder, is there anything that protects people living in areas with where other infectious diseases circulate widely? And is that then a co-protection they receive from co-immunity? No idea. But it's quite remarkable, actually, if you look at it.
Yeah, I remember when we spoke first, you were mentioning that, it's worth asking, is any of the existing diseases playing a role? And yesterday, actually, I saw a review paper that looks at whether helminths. Helminth infections are playing a part. And I remember you asked me about whether we have any indication that malaria might be playing a part into this as well. So.
Yeah, it must be. In my view, it must be some kind of a disease that is very common throughout the population.
Yes.
And with hindsight, may give protective immunity. And if that would be the case, then for once, the African continent actually would benefit from from some other infectious diseases.
Yeah.
But that's of course all speculation and gives ample of room for investigations.
Correct. Yeah.
I see we already have 15 participants, which is very nice.
Yeah, and we have many more coming in. I think last time we probably had 30, 40 people joining.
Yeah.
I'm very happy actually that my colleagues are still able to join, because many institutions are closing now, and increasingly people are starting to log off work for the new year. And I'm just like, oh man, let's make as many contacts as we can at the end of the year. We are going into, for the first time, a fairly unique holiday season. And
well, let me say as a starter, if it's appreciated, you and I could continue a third session like this sometime in the new year.
Thank you.
And then hopefully there are lots of questions from participants, so that they can do the discussion and we can sort of add in. Just as a practical point for this afternoon, I have to leave at 3:45 here in the Netherlands.
Okay.
So that we have about 1.5 hours.
That's fine. That's fine. Thank you so much, Willem, for offering that we can do this again in the beginning of the year.
Well, I see it as a novel and innovative opportunity to actually discuss with younger colleagues some of the issues that might occupy them.
Yes.
And say, how can we actually solve these bottlenecks?
No, I'm quite excited that one of my colleagues told me that this is probably one of the few positive things that is happening because of the coronavirus. So.
Yeah.
So, yeah, I'm glad that we can have a detailed discussion about this, and especially for my colleagues in Ifakara and elsewhere, who can be very isolated from, I mean, sometimes when we are in Ifakara, we get really isolated from the scientific community. And in the past, you could solve this by going to conferences. And so, but now, I mean, we realize there's a new way to do this and really dig deep into certain specific areas. And I think that's quite nice. And thanks also actually for your time that you're accepting to do this.
Well, that's great pleasure. Thanks.
So I think what we're going to do is, to my colleagues on the line, we have, as you remember, we had to cut. We didn't complete the masterclass with Professor Willem Takken last week because he had to leave. But he then offered by way of email that we could complete this process. So we're going to continue from where we left last time, and in those discussions, we will try as much as possible to capture the details of the work, not just the work that Willem has done before, but also some of his general experiences working in this field and expectations, what he thinks is going to happen in the future. It was really nice, Willem, last time when you mentioned that you think indoor residual spraying will be gone in 10 years.
Yeah.
And you know, it's worth thinking about different kinds of the future that we might be faced with, and how do we prepare for, if you're a malaria control expert joining the field right now, should you assume that the future will always be the same, or should you expect certain changes? And the stuff that you mentioned about indoor residual spraying, I think is something that, you know, we would like to discuss a little more. Why do you think, for example, that it would disappear. There are regulatory aspects, like people might say it's not safe, but also the difficulties associated with that. But then I would also like us to talk a lot more about housing, which is also changing a lot in Africa.
Mm-hmm.
It might be that when people get wealthy, they don't want to let anybody spraying white powder into their house.
Well, as you probably know, that has already happened in Ghana.
Yeah. Yeah.
There are districts in Ghana where the population refuses sprayers access to their homes.
Yeah. I mean, I'm thinking about myself too. If I just build a new house and we paint it nice, cream colored in the house, and these spraymen arrive, they're spraying something that is colored. DDT is a famous example for having white color. I don't think I will allow them myself. I'm a malaria control expert too, but I'm not sure that I'm going to let anybody spray white powder on my wall. So.
Okay, shall we perhaps first continue where we ended last time? That was, I think, just after the zooprophylaxis, and the question whether I thought that malaria could ever be eradicated.
Right. Let me find that. I would like us at some point to come back to the GVCR question, but
here, we have to go back a few slides here, Fedos.
You remember well?
One more, two more, and yes, here.
Yes, yeah. So we can start from here. Yeah.
Okay. The question here is, do we think that it's possible to eliminate malaria in developing countries? And we are not there yet. And are we on the right track, or are we missing the focus? First thing is, Fredos, the question I have to you is why you put in developing countries and not just, do you think it's possible to eliminate malaria?
Good point. I think that from our end, there is, this is personal. I mean, there is a general understanding now that in the beginning, malaria was a global problem. Today is very much an African problem, a little bit an Asian problem as well.
Mm-hmm.
And we had a lot of malaria in Europe, a lot of malaria in Holland.
Mm-hmm.
And many of these places eliminated malaria actively. It didn't just disappear, but they did have very active programs to kick it out. And then once they did that, they instituted resilience approaches that were not targeted at malaria, but helped maintain those gains. And things such as improved housing. And in the Netherlands, you guys have this fantastic program of environmental management that makes sure there's no stagnant waters.
Mm-hmm.
I was very impressed to see that when I last visited. And I think that so many of these measures were not targeted at malaria, but they helped a lot. So to the extent that I am tempted to believe that all developed countries, the so-called developed countries, rather, they have very much done the job. They could have to deal with climate change situation if malaria came back, but they don't have as big a problem. So I think in brief, the reason we target this question at developing countries is on the basis of our understanding that even though malaria was in the beginning a global problem, it is today mostly an African problem.
Mm-hmm. Yeah, there I completely agree. I think that to answer the question, I think it will not be possible to eliminate malaria unless there is a vaccine that is so effective that you can, let's say, have entire regions vaccinating and keeping the parasite at bay for a couple of years so that it actually goes extinct. And then you can take the neighboring region and you can sort of an overlapping program and roll up malaria. That would be the ideal hypothetical program if there would be. But we've all seen now, when I first started my university studies back in the late 60s, I was taught that malaria was a matter of maybe 10 more years and then it would be completely gone, because in New York there was a laboratory that had discovered that you could artificially create antibodies against malaria parasites and use that to vaccinate people. That was back in 1969 with the nuisance strikes. Well, we're 50 years on, and actually there are some very large vaccine trials going on, but you and I both know that the maximum protective effect of these candidate vaccines is about 30%.
Yeah.
Whereas if you really want to have an effective vaccine, it must be able to reach at least 70%, if not 80% efficacy.
Correct.
So this already suggests that even if these vaccines come to the market, and that would be very nice because it can protect lives, we will continue to depend on anti-malaria drugs or vector control. And personally, I believe that vector control has most hope and the best chance of being successful, because, and then I go back actually to the epidemiological model of the basic reproductive number. If we can get that under 1,
right.
Malaria would go extinct. And that basically means you have to get rid of your mosquitoes or make sure that mosquitoes can no longer reach human hosts. And that's one of the reasons why the insecticide-treated bed net program has been so massively successful. It has reduced malaria, together with a little bit of IRS, by, in many countries, more than 50%.
Mm-hmm.
But then something happened. About 4 years ago, in 2016, the advances that were made with the bed nets and the IRS actually came to a stop, and we have not seen a further decline in malaria prevalence or malaria deaths.
Right.
Some people say that it's because there was lack of funding, so there was not enough effort. But I think if we look into true science, it was the mosquito that changed its behavior, mm-hmm. or we as entomologists basically never looked what the mosquito really did and where it bit. And you yourself have been closely involved actually in the discovery of the importance of outdoor biting.
Right.
And that there is a certain fraction of the mosquito population that simply does not bite indoors. So out goes the bed net program, out goes IRS, because those are both meant for indoor protection and killing mosquitoes who enter the homes. And in some areas, we now know that up to 30% of the transmission actually occurs outdoors.
Yeah.
Now, and that's one question I would actually like to all the participants, and maybe we can discuss it at the end of the afternoon or the next time. What do you think we should do of how we can address the outdoor biting populations in many, many African countries? Because I think that's one of the things we need to tackle first. But just write that question down and try to formulate an answer for it yourself. And then we can discuss it.
So just for my colleagues on the line, just in case you weren't at the beginning, Professor Takken agreed already that we could do this a third session in January. But today already, he would like us to have a lot more engagement. So if there are people on the line who have specific responses to these questions, please just note that on the chat box, and then we can get you in to do this active, a lot more interactive engagement as well. Sorry about that. Please proceed. Yeah.
Okay. The other question you see here is, do you think it's possible to eliminate malaria in developing countries? Only, in my view, if the economic situation in most countries would significantly increase in the next 10 years.
Yeah.
Some countries are well on the way. Look at Ghana, and in certain ways also Senegal. But what we sadly actually see in many African countries is just as they are about to get sort of on the way to better economic results, that there is civil strife or a civil war or a neighboring country actually invades you. And there are all kinds of problems that prevent countries then actually to continue with their programs.
Right.
Somalia is probably the prime example of it. But look what Boko Haram does in Nigeria and Chad. It makes virtually impossible that any public health program can be executed in these areas.
Yeah.
And so there is also a massive task for the international world to help the continent to get on top of these internal wars, and that the population actually can live there safely and in great security.
Yeah.
And then any public health effort will help. Yeah.
Yeah, I mean, the situation you mentioned in Nigeria is particularly interesting one. It will remain an enclave there with a lot of malaria in the north of Nigeria because of Boko Haram. Mm-hmm. I think a very good example of that is what we've seen with Venezuela. Yes. And I mean, Venezuela was almost zero malaria. It was very close.
They had 10 cases per year or so.
Yeah. And then you had the situation they had there, and at some points they were in the thousands in the past year and 2 years. So I think weaknesses in the health system overall can mean that all those gains are just lost.
Yeah. But fortunately, that's not a reason to say we give up. Yes. Because we've seen if we attack the problem properly, then you can really make progress.
Yes.
And one of the things that you mentioned yourself, of course, is improved housing.
Right.
And if that program could be massively rolled out in many different African countries, we would see that in many areas, malaria would actually slowly disappear to become a problem.
Yeah, I want to ask you a little bit more about that, because as we have seen now, housing is the one thing that many African households are pursuing on their own. They are paying for it with individual household incomes. It's very gradual, it's a very slow process, but we have already, from the analysis by Lucy testing, an improvement from 11% to 22% of African households living in improved houses. And this is continuing. That was by 2015. So it's probably now around 30% of African households living in improved houses. Now, if you just compare the urban and rural areas, I see that there's very little malaria in urban sites than rural, mostly improved housing. And I want to hear what you think about the mere fact that housing is improving so quickly in Africa. How much will this contribute to the fight against malaria?
Well, thank you for that question. I think it's a very important one. I would not be surprised if house improvement would not contribute for more than 50% to the disappearance of malaria. For the very simple reason that if the population is able to afford or build a mosquito-free house, usually at the same time around the environment of that house, breeding sites also disappear.
Yeah.
So the two go hand in hand. It's where we still see malaria in urban areas, and you've seen the situation in Dar es Salaam to a large extent. Whereas in these mega cities, you get urban gardens. People grow vegetables for the market, and in order to be able to do that, they need to create water reservoirs to water their crops. And it's usually there around the edges of these gardens that malaria still lingers. Well, there's an immediate win-win there if a local entomologist would actually take that into hands and say, I'm going to do something about environmental management so that also these last pockets of malaria in the city disappear. Right. It's a relatively simple operation to do, but it could be done in Abidjan, it could be done in Lagos, it can be done in Dar es Salaam, in Mombasa, everywhere where you have a climate highly suitable for malaria transmission, and where you have these urban gardens. Right. And otherwise, as you say, urban development is actually an enemy to malaria mosquitoes. Right. They need clean water to lay their eggs. And in many urban areas, there is actually very little clean water. It's usually highly putrid, very suitable for another potential vector, Culex fasciatus. But that's a different story.
Right. Thanks, Willem. I think we can move forward now. And the next point we wanted to talk about is about capacity for medical entomology. Mm-hmm. And I think the question here, and this is, I remember maybe 3, 4, 5 years ago, you asked me this in passing, and you asked me what my thoughts were about the rise of genomics. And I have to say that my thoughts have evolved a lot about this. And I am personally very worried about the fact that medical entomologies are disappearing. But at the same time, I see the value in the genomics community and how much you can do that. I just would like to hear from your end what your opinions are about this, the happenings now. Can we strike a balance, and how do we strike a balance here? Should we worry about entomologists disappearing or not? How do we handle this situation?
Well, let's first talk about the advance of molecular sciences and molecular technologies, both in the industrialized countries and in the African countries, for that matter. 20 or 30 years ago, the only way you could actually identify a mosquito is catching it, putting it under a microscope, and follow some kind of a manual by Maureen Coetzee or so, and look at the morphological characteristics. And then you would know whether you had a Funestus or a Gambisensis strictu, or something else. Those were time-consuming and highly unreliable tools. Same went actually for establishing malaria prevalence. You had to take a blood smear, put it under a microscope, and more often than not, the microscopes were dusty or filthy, and you couldn't actually see your sample very properly. Mm-hmm. This has all changed dramatically in my academic life, and today you wouldn't dream of it, actually, of going back to these taxonomic tools. Rather, you immediately extract the proteins from the parasites or from mosquitoes, put them in a machine, and the answer will be there, hopefully the same day, sometimes the next day, to tell you with which species you were dealing with. that's not different in Africa from it is in Europe. The incredible risk here is that we see, because this looks like a fascinating program. You mix a couple of reagents, put them in a machine, wait a couple of hours, and you know the answer. But what does a biologist do if he gets a list that from the 100 mosquitoes he examined, 50% were arabiensis and 50% were Gambisensis strictum? If you don't know the environment where these mosquitoes were collected, if you don't know anything about their life cycle or their biology in the field, that is actually rather useless information. You cannot even publish it. And we see the same in Europe here, for example, with agricultural pest insects. People really only want to know what insects did I collect, but then if you ask them, in what crop did you actually catch them? Was it wheat or was it potato? Then they scratch their head and said, what? Should I know that as well? So with other words, I think science, or the biological sciences, has unfortunately very much ignored the significance and the importance of doing simple field work. And in order to turn that around, I think that the African universities and also the European universities should include in their programs for biological students or students in environmental sciences, that in their first year, these students actually are given all kinds of tasks to do field research, and get to know where do you actually collect a mosquito, where does it rest, where does it lay its eggs. You can do a whole series of very simple experiments, and then collect it from your 30 students, and then you get a wonderful answer. And only then you go back into the molecular laboratory and try to fine-tune these answers. And then you can go back to the field and say, hey, this species was only caught outdoors, that species was only caught indoors. And that's maybe the most simple answer I can give at the moment.
Right.
But in terms of capacity building and opportunities for students, you remember yourself that for years, the University of Nairobi had a wonderful MSc program, and many students went through that program, even from Tanzania. And the most important aspect of that program was that the MSc students had to do their field project in the field.
Yes.
They were not allowed to stay within the university for their 1 year master research thesis. They had to go and were actually affiliated very often with an ongoing program on vector research or public health research or whatever. And they went all over the continent. Unfortunately, many of those programs actually were abandoned for lack of funding.
Yeah.
But I think it is just as important that governments and donors provide ample funding to train young people who are enthusiastic to get into the field. And unfortunately, that is lacking, but hopefully a couple of colleagues like you yourself can get together and convince governments and donors to set up a couple of training programs across the continent.
Yeah.
And in my view, that's the only way to turn this loss of entomologists around and make sure they come back.
And do you believe that this itself is a prerequisite for malaria elimination or malaria control in general?
Yes, I do. Because otherwise you run the risk that an epidemiologist is the only knowledgeable person on a control or intervention program.
Right.
but epidemiologists have not received their training in the field. They are trained in developing computer programs and enter beautiful data in there, and you get models out of it. But then the time comes that you have to validate the model.
Right.
And there, I think only the entomologist can validate your model. So you should do end-end, not only one or the other, but please do both.
Right. Yeah.
And I would rather call it.
I have found in many discussions when people working on vaccines or drugs for malaria control go to separate meetings. You have a conference for vaccine developers, a conference for drug developers, and even when they go to the same conference, they go to different sessions. So you see this a lot with the STMH, that you have sessions that are structured for people working on tafenoquine or people working on ring stage of the parasite. And so you have this book and you're selecting which session do I go, and rarely do you find a mosquito biologist sitting in the same discussion as a parasite epidemiologist. And so, I mean, personally, I think there is a problem with the malaria control experts specializing too much in one area and forgetting the other side. But I would like to hear your view, based on your experiences. Is it a good thing that these things are really separated, that the vector biologists are so distant from the epidemiologists or parasitologists?
No, that's not a good thing at all. Actually, personally, I encouraged my students and PhD students, whenever they attended an international meeting, to not go to the entomology sections or the vector control sections, but visit other aspects of the meeting, immunology or parasitology or epidemiology, or even drug resistance.
Right.
Because there you learn aspects of your own discipline that you have never heard of before. The information on vector biology you can quickly pick up either from the literature or from attending one sort of general lecture on where do we stand in this field. And I think that certainly the ASTMH meetings, but also the MIM meetings, have actually gone far too far by creating all these different sections, making it difficult for people actually to get information about their entire field of science. And you do not need to become an immunologist if you've been trained as an entomologist, but at least it's essential that you understand what questions the immunologist is asking him or herself and how they seek to reach the answer.
Right. So thanks a lot for that. I want us to go forward, and I want to ask you a very direct question, but a very interesting one. Also slightly related to some of the things we just talked about. Lots of discussions ongoing right now about gene drives. What do you think? What should we expect?
Okay, gene drive. Gene drive basically means that you select a specific gene that you then insert into one mosquito line, so that, for example, that character of that mosquito is driven into the wild mosquito population. That's what gene drive actually does. And then you can attach another characteristic gene, for example, making these mosquitoes resistant or refractory to the malaria parasites, or causing partial sterility or whatever. Anything is possible with gene drive nowadays. I find it a wonderful tool for research in the laboratory because it can help you to answer an incredible number of questions that we had all over these years. How does evolution actually run through an insect population? and what are the factors that determine that certain aspects actually become dominant and others disappear. However, do not forget that in wild mosquito populations, even if it is one species, there is a huge variety of natural variation. All the time, at each mosquito generation, there is an exchange of genes, and it makes sure that new strains of mosquitoes are appearing all the time. It's perhaps easiest to see in Plasmodium parasites because they have a relatively short cycle and occur in millions. With mosquitoes that goes a bit more slowly. But nevertheless, we should not forget that even of a simple Arabiensis population, as it might occur in Namawala or in Ifakara, there are probably hundreds of different lines flying around at the same time. And if you come back a year later, you find that some of them have a different identity. Now, if you then throw genetically modified mosquitoes into that population, then you must have been extremely lucky that you picked out a gene that all these mosquitoes share. And if you don't, you basically add something to the wild population that wasn't there, but it, in my view, will again go extinct. So personally, I think we still have excellent other tools than having to go for genetically modified mosquitoes. And perhaps the biggest issue here, you know that very well yourself because you've been participating in several expert teams for that. What is the ethical issue? How can you inform the local community properly about genetically modified mosquitoes so that they can take a well-balanced decision? Do we want this or do we not want this?
Yeah, I get it.
Here in Europe, and you have that in the US too, at the moment, because of COVID-19 vaccinations, there are fractions of our population who refuse to become vaccinated. Mm-hmm. And they all say, well, this is all very nice and well, but we have no idea what the vaccine will do with us in the future.
Yeah.
And that's a rather simple example. Whereas I think the release of genetically modified mosquitoes is much more complex. Secondly, there are very few places in Africa where you're only dealing with one specific anopheline species. If you've taken care of Arabiensis, what do you do then with the Phoenesis populations or the Rufipes populations or Marshalli that all of a sudden might find a niche in which they can actually develop explosively because it was abandoned by Arabiensis. And those are very valid and I think important questions. The other issue I really have with it is to what extent are people who are exposed daily to the malaria risk, to what extent are they actually involved in the development of genetically modified mosquitoes?
Right.
It's a fascinating tool, absolutely no question about it.
Yeah.
But from the ecological point of view, I still question the wisdom of ever using it.
This is a I like the English word to use here, but it's it gets me a little frozen when you say that for two reasons. One is that, you know, earlier we were talking about Boko Haram situation in the north of Nigeria, and if you just think about of all the potential interventions that we have, which is the one that we could use that requires no human personnel, no compliance or what? And then you start to say, well, if only gene drives could be successful, this would be a perfect use case. If they could be demonstrated to be safe and effective, this would be a perfect use case because you need to send personnel in there, but you would still make a big dent in malaria. But you raised great points about safety, involvement of the local communities, and I think that. Now, the European Union is debating right now, and they will have a vote in January or February, that includes articles of a possible moratorium on research on gene drive.
Mm-hmm.
Is this something that you would encourage?
No.
Why?
No, I find it wrong to put a moratorium on it.
Okay.
Because we cannot prevent scientists from advancing their knowledge and using their thoughts to the well-being of the planet.
That's so. I mean, I'm glad about that because I think in that point, I'm writing an op-ed now that is targeted at at Brussels. The parliamentarians, they are really asking that. Well, we don't agree with the genetically modified mosquitoes entirely. We don't know what will happen. We don't know what their outcomes will be. But I think also that it is wrong to put a moratorium on research. I think they should still be valuable.
I find it very arrogant to put a moratorium on it. Because, for example, if you would use the sterile insect technology that you can nowadays also achieve through genetic modification, there simply what you do is you throw out a mosquito population into the field, which will be unable to produce a second generation.
Yeah.
So it cannot spread further. And I think it's unethical if you had the tools to do it and the money to do it, to say, no, we cannot do this.
So do you think that we should encourage in any way African scientists to be more involved in research on this, to identify weaknesses and potential benefits?
Yeah. Because the more African scientists are involved in this kind of research, the better they're also able to say what they think about it,
right?
And take the pros and cons.
Right.
But at the moment, it's very often, people don't know what to say because it's such an advanced technology that they find it difficult to comprehend.
Right.
And so I definitely would encourage many young African scientists, please go into this field, realizing that at the same time you also need colleagues who know where to collect a mosquito or how to identify them.
Right. Thank you, Willem. I would like us to move forward a little bit now. This question of housing, I think we have dealt with it, so I will skip that. Mm-hmm. But I want us to talk a little bit about environmental management. And the question up there is posted on the basis of Anopheles finescens, but I think we can just assume it's that word Anopheles finescens is not there. And I want us just to talk about larval source management as an option for malaria control, and whether it's something that whether we are doing a disservice to the community by not exploring more. Should we be considering this in rural areas? What is the value of this? And when I read the works from Brazil and I read the literature on the ecology of species such as Anopheles finescens, there's part of my brain that says, man, this should be feasible. But I also know that the existing regulatory guidelines do not very much encourage this. So what are your thoughts about larval source management in general for rural malaria control?
I think that larval source management is a very much undervalued potential for malaria control. Undervalued because on the one hand, it's very much involved and associated with farming technologies. And many public health scientists and public health entomologists do not want to get into agricultural science or crop production. Whereas you and I know that in fact probably 80 to 90% of the vectors that we're trying to control are created in agricultural fields by human activities.
Right.
One of the nicest studies done that I'm aware of is done by Susan Imbahale in Kenya for her PhD thesis, where she actually compared different farming systems in relation to larval mosquito production and adult mosquito production. And lo and behold, she showed very clearly that farmers who were ignorant about this were the most productive mosquito breeders. And those farmers who had been instructed how they could actually prevent mosquitoes from breeding, for example, by introducing intermittent irrigation, making sure that the water would run through and would not stand still, and so on and so forth. Their mosquito populations actually ceased to exist or became of such low densities that it became manageable. And it's a very simple example. And I know that several of your colleagues have done similar studies elsewhere in Africa. But unfortunately, they don't get published in Science or Nature. And not at all in the opening lecture of the ASTMH or MIM, whereas I feel they should be presented there. Because once you see how quickly you can actually reduce a mosquito population, once you understand how you can control these breeding sites, things would go a lot better.
Right. Yeah. I mean, Willem, in Sudan, they have a program of dry days in the rice irrigation systems. And, you know, you start to think about what here is the role of the farmers. What role can they play to encourage this level of source management? And based on the studies that you've done with people like Susan, for example, could you just elaborate on partitioning here of duty, where the researcher comes in and where the community comes in? What do we need to do to make sure that, you know, we can expand this level of source management?
Well, let me give you an example. We've recently completed an integrated malaria control program in southern Malawi, where the focus was on community participation.
Right.
And we focused, and we had because everybody was receiving a bed net through the government program once every 2 years, but malaria was still a huge problem. So we added 2 additional interventions. One was house improvement, and the other one was larval source management, done by the community. So we first asked the communities, what is your most important problem in terms of health? And when they had sorted that out, it became quickly clear that that was malaria. And then members from the community were actually attending workshops where they were trained in the biology of the mosquito, in where they would lay their eggs, and they themselves came up with ideas of larval source management. So this was really a community-driven program. It was a research program, of course, but the success was really fantastic because in those villages where the community themselves actually controlled the breeding sites, the mosquito populations, the adult mosquito populations reduced by 80%. The difficulty at the moment is, how do you convince communities to continue with these programs? Because it should actually become part of your daily activities.
Right.
And they have to do something themselves.
Yeah.
But for example, in areas where you can do intermittent irrigation, like in Sudan, but that was also in the Moya irrigation scheme in Kenya, and we've done it in Senegal too, the rice crop doubled So there was a benefit for the farmer in terms of crop output, and there was a benefit for public health by having far fewer adult mosquitoes.
Yeah.
And I think we are not taking advantage well enough of this knowledge, and at the moment it's really stays relatively localized knowledge that is not being rolled out much further. And it's not high-tech science. I completely agree. But why not use simple techniques? House improvement is also actually not high-tech science.
Right. I mean, we were earlier, we were talking about outdoor biting. And actually one of my colleagues has put a note here on the text, saying that he would like to make a comment about that. Alphonse, at some point I'll invite you to do that. But Willem, when we were talking about outdoor biting, we start to think about, well, if you control mosquitoes at source, this wouldn't be a problem. So maybe there's even a greater motivation to go these levels outside.
Mm-hmm. I completely agree with you, because what you do, of course, is you intervene in the nursery of the mosquitoes. So fewer mosquitoes make it to become adult mosquitoes, and therefore automatically the number of biting mosquitoes goes down.
Right.
And also there are no adult mosquitoes who can participate in the future generations.
Right.
So it's
on the
win-win
specific
situation then.
Sorry, I interrupted. Go ahead.
No, just continue.
Yeah, so on the specific question of Anopheles fenestus, and I had an email conversation yesterday with Joe Lyons, he was saying something that is very much in line with what we see in this figure here, which is that it is very difficult to find the locations where Anopheles fenestus breed. But in the villages where the vector assists, it carries so much of the malaria. In the place we work in southern Tanzania, and it's 80–90% of all the transmission events are mediated by this vector. The places where it breeds are not many, there are very few, and they are not easy to find. But when you find them, interestingly, is they have certain specific characteristics. And the ability to characterize them then allows you, if you can characterize them, then allows you to find them every now and then. They also carry this property that they are permanent or semi-permanent mostly. So theoretically, I want to believe that first, because these habitats are not so many, they're few, they have defined characteristics. They're not like for Anopheles gambi that are different types who print small, dry, they're shorter. Maybe, just maybe, a very good larval source management program here, coupled with bed nets or IRS, should do the job against Anopheles fenestus. Would that be a reasonable assumption?
One thing we have not discussed yet in terms of larval control, of course, is the application of Bacillus thuringiensis israelensis.
Right.
Probably the world's most widely used mosquiticide of biological origin. It's very important. It's not synthetic. It's a toxin derived from bacteria. And wherever BTI is being used, you see that anophelines disappear within 48 hours. So if at 10-day intervals you keep treating, after 4 to 5 weeks, you usually see a total collapse of the adult mosquito population if you manage to treat all these potential breeding sites. Now for fenestus, in my view, there is a huge opportunity to do so. If you do not start in the wet season, but you start your program at the height of the dry season, because that's, of course, when most of the breeding sites actually have contracted and are also more easily to find. And in that way, you should be able to mop up existing Funessus populations. It may not be possible everywhere, because if you have like a very big swamp here in the left-hand corner in panel A, that swamp may be so deep and so large that even at the end of the dry season, you still have water. And unfortunately, Funessus mosquitoes actually can hide very well in between the vegetation. Unlike Arabiensis or Gambi, for that matter.
Right.
There is another reason why I think we should focus more on this kind of larval source management. And we touched it a little bit the last time, but if Anopheles stevensi would manage to advance further into the African continent, it could well also start using similar breeding sites as Funessus. So if there is a lot of experience is how you can actually use larval source management to get rid of these mosquitoes, that would be very useful.
Thank you. Thanks a lot, Willem, for this. I would like us to take a little break here and take the questions.
Okay.
And maybe ask the participants to actually, in this specific session, to come up in person and make those brief comments. This is a special request from Professor Willem, so I think we're going to do it that way. Please, for the sake of time, we're going to ask you to be very brief and make the comments. The first one is by Alphonse. Alphonse, do you want to make your comment on outdoor biting?
Please turn your microphone on.
Alphonse, you'll need to turn on your microphone if you're there. Okay, if not, we go to the next one. Dr.
No.
Issa?
No.
Hello? Yes, Alphonse, go ahead.
Yeah.
So I had a problem.
Alphonse, you're logged in on 2 machines. You need to switch off one so that there's no echo. Okay,
Okay, can you hear me?
Yes, please.
Okay, so there's an internet problem here, Frederick. So, but if you can all hear me, then I can proceed, right?
Go ahead, yeah.
Yeah.
So I had my views on the question that Professor Willem has asked about addressing the issue of what outdoor biting mosquitoes. So I've actually gone through a number of literatures to see where a mosquito has been eliminated in other countries. And what I'm going to say are my views, and I'm going to divide them into 3 categories. So first of all, I'll say we can address this problem. Actually, what I'm going to say will not only address the outdoor biting mosquitoes, it will also address the indoor biting mosquitoes. So first of all, by targeting the immature stages of the mosquitoes, I mean the larvae. So of course, we have spoken about this, the larvae side, the targeting of breeding sites. So I am a staunch supporter of environment management by through larval source management, because this has been done in some countries and it completely eliminated the mosquito populations. So like I read a paper about mosquito elimination in the Middle East, especially in Palestine, in the 1940s, something. And they eliminated mosquitoes entirely through the management of the environment. I mean, targeting the breeding sites. So how did they do this? It was the active work of the researchers, scientists, mosquito control experts, and the support from the government. So every citizen was educated about mosquitoes and how they can be eliminated. I mean, every person was responsible. The education was to every public, to every person, was responsible to make sure that the breeding sites doesn't exist in their areas. And other countries actually formulated strict laws and regulations to make sure that every household makes sure that there's no breeding sites within a certain perimeter of the household. So with laws and with education, people can eliminate the breeding sites and therefore reduce significantly or eliminate the mosquito populations. I've been working in some areas, in some villages, and you see there's some breeding sites in some areas where actually if the people knew what these breeding sites means, they could easily destroy that breeding sites. But they neglect, most people neglect the breeding sites in the environment. And the local government doesn't take any action.
This is Willem.
So I think there's that one, the government and the education of the people to target these breeding sites. And those breeding sites that are hard to reach, they can be reached actually.
Hey, Alphonse, I just muted your video temporarily because I think Willem was trying to say something.
I have a question to you, Alphonse. It's very interesting what you're telling and what you found.
Hello?
But the purpose is that you ask us a question concerning the seminar here, because we all can come up with all kinds of examples of how this works, but I would be very curious, and Frederick as well, what is your actual question that you have to us?
Okay.
Yeah.
So Frederick, I think I haven't completed yet. I think I was
Alphonse, just in case you can hear us, I purposefully muted your microphone just because Willem wanted to pass a message that it would be nice for you to specify very briefly what your comment is or what your question is, and so that we can proceed, so that it doesn't take much. I think it's really important that we get your views on this, but just try and be very brief with and ask your question directly or make the comment. So
okay,
go ahead.
So I'm going to the next point. The other way we can use to target the outdoor biting mosquitoes is the use of this wonder drug, ivermectin, which we know that when mosquito takes a blood meal containing this drug tends to minimize or to shorten the life cycle, the lifespan of the mosquito, so it can't infect or it can't bite another person. So we can also consider the use of ivermectin as a means to address the outdoor biting mosquitoes. That's the second point. The third one, apart from ivermectin, we can consider the use of repellents. Repellents can work very well with outdoor mosquitoes. Like whether it's short-term repellents that people apply frequently on the skin, or it's the repellents that can last long. all means of repellents can address this problem of outdoor biting mosquitoes. So in short, we could focus on those three things: the use of repellents, the use of this wonder drug ivermectin, and the targeting of the larvae stages to destroy, to prevent, to finally minimize the mosquito or reduce or eliminate mosquito populations.
Thank you, Alphonse. That's an excellent point. I'm going to hand it back to Willem, please.
Thank you, Alphonse, for these comments. So the first one is you propose to put more emphasis on environmental management. And I think I've explained already that I'm very much in favor of that, if it is locally possible, particularly with involvement of the community. The second point is the use of ivermectin, because it would actually kill the mosquitoes indirectly. I don't know whether you were present at the previous session we had a few weeks ago, but then I said, yes, ivermectin might be used as an immediate tool or intervention tool for the moment, but you introduce the same problem as you do with insecticides. It will lead to resistance of the mosquitoes to ivermectin because there are always genetic selection processes that let a few mosquito species escape, and then you're back to square one. So I'm not very much in favor of using ivermectin as a regular tool for malaria control. The third one is repellents. We've also spoken about repellents quite intensively and extensively the previous time. The problem with repellents alone is they can give protection, but they do nothing to the total density of the mosquito population. So unless you wear repellents all the time, it will do nothing to the malaria situation. And in fact, we still have to see an example of where malaria control has been achieved with repellencies. And there have been some beautiful reviews about this, studies using repellents. And Fredos, if I'm right, none of these studies actually provided enough evidence to say, yes, we can actually safely rely on repellents only.
I think I've seen the evidence. The best evidence we've seen now is from Sumba. Sumba trial, and they have come with, so for personal level, personal protection for the duration, you can get some protection. But one of the challenges they have had is the issue of compliance, especially for topical repellents, because people don't do repeat use. They don't reapply this all the time. Yeah. So there is all that. Personally, I have a concern about them only because they are a commodity and they do not solve the problem for the long term.
Well, I remember a program in Zimbabwe a long time ago where soap, pieces of soap for the local market were actually impregnated with a repellent in the hope that that would actually give people protection. But it was the same kind of thing. People would not adhere to it too well, or it would wash off rather quickly. People were very careful with this soap because it was rather expensive. So it wasn't used properly enough, and therefore the program died a quiet death. And you yourself are actively involved actually in research to see how spatial repellents can be really become made effective. Yeah. And I think in the next few years, we'll probably see a major advantage there.
Right. Thanks a lot. And Alphonse, these are great points that you made, the issue of larval source management, mass drug administration with ivermectin and spatial repellents, as Professor Willem has explained. I think there are challenges here and there, but I think for research purposes, there's room to continue to gather evidence around those. Now, there are a few additional questions here, and I would like us to answer those as well. But before that, Willem, I would like us to go back to something that we didn't get to ask you last time, but I think it's really, really important for us, combining two issues. So I'm going to ask Marcy and Isa to just hold briefly, and then we'll come back and I will ask them to ask the question. But first of all, Professor, there was three items, multi-sectoral approaches, integrated vector management, and wholesomely under the concept of the GVCR.
Mm-hmm.
So I'm going to pull this back because it's a slide that we skipped, but which I think was really, really important, and I want to hear your views on this. You have been a major player in the development of the Global Vector Control Response Program,
Mm-hmm.
The WHO. And I remember that one of the last times I was in Holland was at a meeting that you organized together with WHO to discuss this whole thing. This was also one of the only programs that was approved at the WHO World Health Assembly. I think this was in May 5th last year. Why, Willem, do you think that it is so important to go this integrated way? And what is the simplest way we can communicate this? Because, I mean, reading through the documentation, it's a fantastic program, but somehow it's not implemented this way. Instead, people still have very vertical programs targeting a single disease, XYZ. What are your thoughts?
Okay. The immediate reason for developing the Global Vector Control Response by WHO in 2017 was not malaria, but was the outbreak of the Zika virus in South America, which at the time was considered as a world disaster. And in fact, WHO declared it a pandemic, which they don't do very often. And if you combine that with the advances of dengue and chikungunya across the world, WHO all of a sudden realized that they had actually completely ignored in their programs the vectors. So what then happened very quickly was that within a month, and that was highly unusual, there was a committee working on the global vector response, and I think never in the history of WHO has a program actually been written and approved by the World Health Assembly within 9 months. That was a record control, a record in terms of accomplishment. Now, why the global vector control response? It was realized that WHO had a division of malaria control, it had a division of parasitic diseases, and believe it or not, dengue and chikungunya were under the parasitic diseases. But all these programs were not integrated at all. And what we did when we developed the global vector control response, we said, a vector is a vector. And whether you control actually an assassin bug or a malaria mosquito or a filariasis mosquito, it doesn't really matter. The science behind it is very similar, because what you want to do is interrupt the transmission of a pathogen or a parasite to the human host. And that's actually the principle of the global vector control response. And then secondly, we realized, having consulted all kinds of experts around the world, that in most countries, these programs were done mostly vertically. In the Ministry of Health, you had a section for malaria control, and you sometimes had a section for trypanosomiasis control, or a section for arboviral diseases, but all these sections would never talk to each other, whereas there are lots of similarities in approach. So what we did here is we said, let's first focus on the intersectoral collaboration. Let me give you an example. if you work on malaria control in an urban area, very often the Ministry of Health makes sure that there are anti-malaria drugs. They get the bed nets. They make sure the bed nets are being distributed. But very often it is completely forgotten that the Ministry of Planning or the Ministry of Urban Development is not at all involved. So where do they get the information of the number of bed nets they actually need? And what is the density of the population across the city, for example? Or are the water engineers involved? Because they probably could actually do something to standing water to make sure that your program becomes more effective. So the first pillar of the global vector control response is intersectoral collaboration. And we've encouraged, and WHO has encouraged and is still doing that, all member states to set up a national committee on intersectoral collaboration for vector control.
All vectors.
The idea here is that countries themselves put people together from all kinds of departments and programs and discuss together what are the major vector-borne diseases that we're dealing with in our country and where are the similarities where we can control them. And for example, the control of filariasis, Butyraria bancrofti, and malaria in eastern Tanzania should actually be done by the same group because very often you're dealing with the same vectors. And if you notice that dengue is on the rise, and dengue is most likely being vectored by Aedes aegypti, why would not the malaria entomologist also give advice how you can actually control mosquitoes in the household? These are three very simple examples where this can be done.
Right.
The second pillar of the global vector control response is surveillance and monitoring. We noticed that in most countries there were no proper long-term surveillance programs going on. So when there was an outbreak, the first thing you had to do is find out where are these vectors actually, and do we know enough about them? Mm-hmm. The third line is capacity building, what we already discussed earlier this afternoon. Training of entomologists at different levels, technical level, but also academic level. Mm-hmm. And if you combine those pillars then together, we call this then integrated vector management, because with the participation of different members of society, you can actually much better fine-tune your control program.
Right. Yeah.
And as you say, I think it's very clearly written in the GVCR document, which you can easily download or find on the WHO website. So I can only recommend people look at it, and you probably will recognize a lot of what your own program is already doing.
Right. So, I mean, at the MIM conference in Senegal, mm-hmm. We had a panel discussion, I remember, and one of the comments was that if you show a pool of water to an entomologist, they will think about BTI, even if the pool of water is small. Mm-hmm. But if you show the pool of water to people in the Ministry of Housing, they will bring a tractor and close it down. Mm-hmm. So in other words, things such as larval source management, if done by ministries other than Ministry of Health, they can be done better and much more permanently.
Absolutely. So in fact, if, for example, in the Ministry of Health, someone wants actually to do something about the mosquito problem, and and he or she has actually noticed that there is quite a bit of standing water in an urban or rural area, we encourage them to contact the Ministry of Public Works and discuss it with them and say, listen, can you do A, B, and C? And that would help us very much. You can also call a colleague in the Ministry of Agriculture and say, hey, did you know that your irrigation channels in the rice fields are actually the major source of mosquitoes? Can we discuss together whether there is an opportunity to actually modify the irrigation or sometimes even dry the fields? That would help me very much, and it probably would help you as well.
Yeah.
And those kind of intersectoral contacts were virtually non-existent,
right,
or sometimes not approved by someone higher up in the ministry, because it would. And a major bottleneck then, for example, is each ministry has its own annual budget. So then your colleague from the Ministry of Public Health might say, yes, I'd love to close these water bodies, but can you pay for it?
Yeah.
And that's where the trouble starts,
right.
Because it's often very difficult to transfer money from one ministry to the other one. And this is where we think that intersectoral collaboration at the basis is so incredibly important to make very much advances in this field.
Right.
And we give examples in the Global Vector Control Response how you can do that.
Well, one of the suggestions that was made in the days when Fred Soper was working in northeastern Brazil, he had the presidential backing. And in Tanzania, we are very lucky right now that we have presidential goodwill for lava source management.
Mm-hmm.
And the suggestions that were being made at the time was, for things such as this, you don't need to align them to a specific ministry, but rather you want to put them in the office of the president. And then just have one government approach pulling in there. So yeah, thank you so much for these comments, Willem. I would like us to move further back to where we were before, and I want us to talk about something that is a lot less technical but important, and maybe we discussed it a little bit last time, and then after that I would like to invite Dr. Issa to make some comments as well. But first of all, I want us to discuss go ahead.
Fredros, just one minor comment. I have 10 more minutes.
Okay.
And I suggest that we then that you reschedule a third session.
This is interesting. So
because it's nice to be able to discuss this. Yeah.
Right. That's fine. So I think we can very quickly go through this, and I don't know if we discussed the issue of climate last time, but those are the two things that
no, not yet. No.
Yeah. So why don't we go to that, and then we can talk about this again. We are having challenges with climate change in the form of floods, especially in Africa. One of the biggest manifestations is flooding, actually.
Mm-hmm.
Some imbalances in terms of the rainfall patterns. I would like to hear your opinion, Willem, on whether this is something we should pay attention to, and in what ways you think it can affect vector control in Africa.
Okay. When talking about climate change, most people will associate it with a change in temperature. The Earth temperature will, on average, increase with 2 to 3 degrees centigrade in this century. And very few people realize that there are many other aspects associated with climate change. And I think, indeed, the most important one is the changes in precipitation and rainfall, causing flooding, and all kinds of misery left and right. In some desert areas, there will be less rain, and in some areas that already receive a lot of rain, there will be even more rain. And the El Nino effect that used to affect us approximately every 7 years has already become accelerated and is usually coming back in a cycle of 4 to 5 years at the moment, and much more heavily and much more closely to the African shore than ever before. So we now sometimes see flooding in Somalia, in Kenya, in Tanzania, where it never used to occur before. How are we going to deal with that? Because the flooding itself is already, of course, causing disaster, because in many cases villages are being washed away, lives are being lost, livestock might be lost, and so on. But these are usually factors that of a temporary nature. A couple of weeks later, the water recedes, and that's it. But only then the problem for vector-borne diseases actually becomes highly relevant, because these large pools of relatively shallow standing fresh water all of a sudden become potential breeding sites for mosquitoes that never were there before. And I'm afraid we're going to see this much more often than we've seen in the past. How we can deal with this, because we cannot stop the rain from coming from above. We do not have that capability of doing so, but we can anticipate on it. And again, if you would collaborate or work together with the Ministry of Public Works or the Ministry of Agriculture, possibly a drainage system can be developed that the water can actually be drained as quickly as possible, and that the occurrence of these very large lakes, temporary lakes, will be minimalized. We've seen it in Mozambique as a prime example a couple of years ago. Tremendous hurricanes and flooding where it never used to occur before. And 3 months later, there were very big outbreaks of malaria in an area which normally is as dry as a bone. And if we are prepared to know this and actually can join hands with the government in other departments, I think we can possibly reduce these impacts of climate change. But it's definitely something that will have to become integrated in a national program.
No, thanks a lot, Willem, for these highlights. And I imagine that this is one of the things that we would have to do for much more than just malaria. Because I mean, you see, with some of this, it comes. Then you have Rift Valley fever. You have
what you see in urban areas. You get far more Aedes aegypti than you had before.
Right. Yeah.
Because all kinds of receptacles will fill up with water.
Right.
If people are not aware of it, they're actually sitting in a sort of infectious area where there was none before.
Right. Thank you so much, Professor, for your time again today. I know that your time limited. We had 2 questions on the line there. One, I don't know if you can read them, but one is by Mercy, who is also left. But it's about drones, and then the other is about gene drives. So maybe we just use the last few minutes to answer those, and then we can reschedule the continuation of the masterclass. Yeah. So are you able to see the questions?
Where would I be able to see them?
I can read them for you, actually. So the first one is from Dr. Issa, and the question is, how can we compare the magnitude of risks between embryonic germ cell technology and the gene drive technology? How far is the germ cell technology in application? Do we anticipate gene drives as a vector control to be rolled out anytime soon? That's the first question. The second is a question from Mercy, and that is, what do you think about the use of drones to identify and map larval habitats versus the use of community members themselves? to do the same job. In general, what is your take in the use of drones regarding this?
Okay, well, I'll try to answer both questions quickly, and then we can possibly start with them the next time.
Right.
Gene drive versus germ cells. I think we've already discussed gene drive extensively today, and that I'm not very much in favor of seeing gene drive as a technology for field application. But
Right.
it's definitely a very interesting tool for the lab. I don't know enough about the germ cell programs. That's something that is relatively new. And I think we still first have to see what germ cells technology can actually bring in the field or to the field that would be to our advantage. So it's difficult to say at the moment which one would be preferable, gene drive or germ cells. Let's keep both in the basket at the moment and see how they develop and what can be done with them. But again, I would recommend that also African scientists get themselves trained in these technologies and pieces of science so that they can actually actively participate in ethical discussions that are so necessary before they're being applied. Now, if we go back to the drones, that's actually simpler. Yes, there is definitely a role in using drones, not only for monitoring and surveillance of breeding sites. They can be used already for that because they also can sense very much wetland areas and so on. But we can also use them for larval control, for example. If you have a program on BTI, why not use drones? Because there is precision technology that you can reach areas that are very difficult to reach otherwise. You can possibly use drones in the future to put out mosquito traps in a village. I think the possibilities are numerous, and we are still at the start of using that technology. And with solar energy, the use of these drones will also become lots and lots cheaper. So they can be reused again and again and again. Some countries already use drones to deliver drugs to remote areas, which is another very practical and useful application. Because whereas normally you needed 2 whole days in a car, now it's usually a matter of 1 or 2 hours, and all the remote villages have received their drugs.
Yeah.
So let's be clever and use it.
Thank you so much. Thanks a lot, Professor, for making time for a second and also promising a third. This is greatly appreciated. I think what we're gonna do now is when we do the third session, we will start with this. And there's one component that I would also like us to bring early on, and that which is the issue of public engagement. We talked a little bit about it in the past. I would like us to talk more about that also next time. I'm also going to request my colleagues joining that for the third session with Professor Willem that we actually submit questions much more widely. So if you have any questions that you would like us, many of us are aware of the work that Professor's done before, so you can just, if you think there's a question you want to ask, you can submit that in advance, and then I can make a new set of slides for the discussion to make that going. So I think that would be in January. Now I just want to wish you a fantastic Xmas holiday, Professor. Wish you good health and a great time with family in the Netherlands. And again, to thank you so much for making time for this. I hope that
thank you very much,
enjoyed the discussion as much as we did.
Thank you very much, Fredros. Like you, I wish all the participants actually a very nice holiday, which I'm sure you have deserved. And I would look forward to seeing you again and talking to you early in the next year.
Thank you.
Yeah. Okay.
Thank you so
much. Have a good day.
All right. Have a good time. Thank you guys on the line. I'm going to close the call now. Again, we will have a video version if anybody wants to have that at a later date. But thank you for participating today. And for the next session, you can share questions if you want. We will have many more of the master classes in the new year. And you know, you could send the questions directly to me. I will provide a calendar of which ones are coming. Just for your information, in case you want to know, we have a masterclass planned with Professor Joe Lyons coming up. A nice one from Indra, Professor Indra, which will focus mostly on Aedes aegypti and all that, and then many other interesting ones that we're going to have. Hopefully, we will have a talk with Professor Moshe from the north. We have to figure out how this is going to work, but hopefully we're going to do that. And as you remember, Abraham Zava's masterclass didn't take place, and so we will have that also in the beginning of the year. The other one that is confirmed now is Sylvie and Pierre Carnaval did confirm that they would like to do a second one as well. So we will have a second session with them as well in the new year. Otherwise, I wish you all a fantastic week. I know this is our last scientific meeting for Ifakara Health Institute. So thank you all to my colleagues for participating. And I wish you all a wonderful season ahead, a great weekend, and a great time in general. Bye-bye.
Bye-bye, bro.